The dean of a university estimates that the mean number of classroom hours per week for full-time faculty is 11. As a member of the student council, you want to test this claim. A random sample of the number of classroom hours for 8 full-time faculty for 1 week is shown in the table below. At alpha equals 0.05, can you reject the dean's claim? Complete parts A through D below. Assume the population is normally distributed. And then you're given 8 values that are random samples: 12.4, 9.2, 13.9, 6.2, 4.4, 9.8, 12.4, and 9.1. Now, this particular problem is going to be based on the fact that you understand different parts of it. So first off, let's go ahead and look at this last statement right here. We'll assume the population is normally distributed. And we're going to look at this right here that says that we have 8 full-time faculty. It's a random sample of the number of classroom hours for 8 full-time faculty. So n is going to be equal to 8. Then we're going to look at this part. The dean of a university estimates that the mean number of classroom hours per week for full-time faculty is 11. Now, let's key in on this word right here. Is. In mathematical terms, the word is means equal to. Okay? Now, you want to test this claim as a member of the student council, which means that first off, you need to go ahead and write the claim mathematically and identify your null hypothesis and your alternative hypothesis. The first thing to remember is that the null hypothesis is always a statement of equality. And we're going to pull that from what the dean is stating as the mean number of classroom hours. And since this represents a population, it's going to be the population of faculty at the school. We're going to use mu to represent the mean. And the mu, in this case, is going to be equal to 11 because that is what the dean claims. Therefore, your alternative hypothesis, H sub A, will have to be stated as mu is not equal to 11. Remember, like I said, the null hypothesis is always a statement of equality. Therefore, the alternative hypothesis will be a statement of inequality. It will either be not equal to, or it will be less than, or it will be greater than. There will be no equality in here. So now that we know that, we're going to do the second part of this, which is to find the p-value. So as I stated, use technology to find the p-value. You can do this using a number of different technological tools, but since StatCrunch comes integrated in our platform, and then what you'll be able to do is actually perform some tests. So let me move this out of the way, and then we will look specifically at the values in StatCrunch and how we're going to use StatCrunch to find a p-value. So now once we've copied the data into StatCrunch, as you see over here, we will left-click the Stat button, and it'll give a pop-up menu. And since this is normally distributed, or we're assuming the population is normally distributed, but there are only 8 values in this distribution, or this sample, we'll use the t-stats. So we'll scroll down and highlight t-stat, then we'll highlight one sample, then we will left-click with data. And it brings up this new pop-up window. So left-click the column that your data is in this case we haven't renamed it, so it's just var1. And then we want to do a hypothesis test for mu, and we know that mu is equal to 11, so we type in 11, and you'll notice that the alternative automatically auto-populates the value. And if we had wanted to change to less than, we could, and this would be greater than or equal to, but right now we're just simply starting with the less than. And we will simply left-click compute. and that brings us up with a new table. This table is going to have the p-values in it. So our p-value, calculated using technology, is equal to 0.284, which we will round to 3 decimal places. Notice that our table also has our t-statistic. It also has the degrees of freedom. In addition, we'll have the standard error and also the mean of the sample. So now the next part that I want to do is go ahead and determine whether or not to reject or fail to reject the null hypothesis. Okay, so we'll decide whether to reject or fail to reject the null hypothesis. So we decide whether to fail or decide whether to reject or fail to reject the null hypothesis. So in this case, we want to compare alpha, which is 0.05, and p, which is 0.2844. So since p is greater than alpha, we will fail to reject the null hypothesis. So now, since we've decided to fail to reject the null hypothesis, we need to interpret the decision in the context of the original claim. And remember, the original claim was that the dean of the university estimates the mean number of classroom hours per week for full-time faculty is 11. Okay, so going back to part C, since p is greater than our level of significance alpha, we fail to reject the null hypothesis. Therefore, at the 5% level of significance, there is not sufficient evidence to reject the claim that the mean number of classroom hours per week for full-time faculty is 11. And that is the end of the problem.